Morning, Chris Shank here with Case IH. I'm Crop Production Product Specialist. We're here at Arnold's, and we're going to look at the sandbox trailer and a row unit comparison of the 2000 series planter row unit versus a competitor row unit. When we start looking at the row unit itself, we'll look at up front. We start with a leading and trailing opener disc. So when you think about that, we look at a leading versus trailing opener disc. We're going to see this opener disc go through the soil, through our residue, our hard areas of soil, with a leading edge versus a blunt double edge opener disc right next to each other. Okay, so we can think about that as a steak knife versus a butter knife. Okay, it's going to go through, slice through that residue, penetrate into the soil, and so on, a lot easier. Then we can move around to the gauge wheel. On the gauge wheel arms, we're going to be going through and running a pull style gauge wheel. Okay, so our pin's mounted up front, and we're going to pull this gauge wheel through the field. So when we look at that, we're going to think about a wheelbarrow concrete. If I take a wheelbarrow of concrete and I push that wheelbarrow over a bump and through the sand, it's going to have a tendency to ride rough, push hard, and so on. If I pull it over the same bump, same sand, we're not going to see as much berming of that soil in front of that wheel, and it will ride a lot smoother. So naturally, we're going to see this row unit ride smoother than a competitor one. The other thing that we're going to see is how much load we're going to see on these pins. As we push those gauge wheels, we're going to see them try and push themselves apart. All that load has to come back to their pins back here. The pins on their competitor row units are maintenance. Okay, these are daily grease fittings. There are no daily grease fittings on the Case IH row unit. Okay, pull style versus push, so it's lighter load when we're going to see this move through the soil. When we look at the back as well, we can see the profile of our gauge wheels. We go with a relieved inner diameter gauge wheel. That's going to allow us to carry the gauge wheel weight or the row unit weight roughly 2 inches away from our seed trench when we're forming that. Okay, competitor row units run with a flat profile gauge wheel, and they utilize the gauge wheel and the disc to go and form the sidewall of their trench. Okay, so we're going to see what the difference is on the pressure there. But as long as we're in the back here, we're going to take a look at our shoe. Our shoe, we can see our seed tube in this case is coming down right inside the shoe. This shoe is meant to keep the trench open versus the compacted seed trench of the competitor row unit. Okay, in front of that shoe is our forming point. This is going to go through and wipe out the W that we typically see in the bottom of every double disc opener seed trench. Okay, so as we go through and set this unit down, so we can see that the slack is in the chain, the row units are on penetrating into the soil. As we move them forward, we're going to look at what's happening in front of the gauge wheels. As we're moving forward, all that soil is moving in front of the gauge wheel. On the other side, we see how that soil moved as well, right? It has a tendency to push that harder. All that load is seen back at the pins in the rear. When we look in the seed trench itself, we can look at our fracture lines. As that seed trench is opening up from the double disc openers, we can see the fractures in the sidewall. So when we push on the sidewall, we see they're very forgiving, very soft sidewalls. Okay. The last thing we want to take a look at, in the bottom of the seed trench, yes, we both leave a W in there, right? When we look at the other side, there is a W in that trench as well. Our forming point goes through and wipes out that W, flattens that out. So when our seed comes down, whether it is dropped with a standard tube or it is placed with a speed tube or the advanced seed delivery, it's going to be placed always at the same depth. Okay, so we have a softer sidewall here. We can see that the row unit weight is carried roughly 2 inches away from the seed trench. In comparison, on the other side, we can see that that W is there consistently through. In some places that W crumbles down, Other places it's straight up. So what you can see there is a difference in depth of that seed. The actual seed depth can be on the bottom, on the side, it can be on the top. On the other side, it can crumble back like down here or up front. Okay, we see that the row unit weight is carried all the way up next to the seed trench. When we push on here, we can see that this sidewall is much firmer. Now as we move through the closing system, we're going to take the double disc closing system. These are 9-inch blades. Okay, our prior planter had 8-inch. When we go through, the idea here behind the closing system is to zip that back closed. So as we pull that forward, we're going to see it close from the bottom up. Okay? We're going to watch and try and place all that moist soil that came out from the bottom of the seed trench back down into the bottom. Okay? And we look at the press wheel. On our press wheel, we see that we have no pressure in the center. Zero pressure on the center of the seed trench here. Okay, no air pressure in there. We do have lugs here on the sides for firming. Okay, on the outside we're going to see the chevron pattern. Okay, this is intentional so that if we get into dry crusting situations, we're going to have a tendency to crack open right in the center of the seed trench so that that corn can emerge or soybeans can emerge. That crop can get out easier. Okay, so when we roll this over, we're just going to go through. We've already closed it. This is just going to go through and press out any air pockets. Okay, and right down the center we can see that we have our pattern there. We also look at how the profile is. So as the sun and the wind come across this, we've got a flatter surface, right? Less surface area, we get less dry out, and so on. Okay, we keep that soil structure, density and moisture all back right where it was. Bottom of the seed trench all the way through the soil profile. So the seedling doesn't know any difference on what's happening. On the competitor row unit, when we go through and use the V-press closing system that's incorporated with a flat profile gauge wheel, we're going to watch as that goes through and closes. We're going to see dry soil sometimes mixing in with the moist soil down to the bottom of the seed trench. So that's where we get that mixing action of dry versus moist soil. When that happens, now we can affect germination rate, right? So if we have dry soil mixed down at the bottom, we can slow down our germination, therefore we slow down our emergence, and we need to wait for a rain event, irrigation, and so on. When we look at the profile as well, we're going to see that there's a lot of surface area on this style closing system where sun load, wind can come through and start disrupting what's happening to that soil. Okay, so we look at a visualization or a drawing of it. When we look at storing that soil in the reduced inner diameter, we can see that that moist soil line is still right here in the center, right next to the trench. We have our dry soil where it heaved up into the storing area. On the other side, we can see how it presses between the disc and the opener disc and the gauge wheel. That moisture is up here, it's pressed in. When we come back and we're going to close, we're going to see some crumbling action from the top, some from the side. We're going to see a mixture. The other thing that we end up doing with our press wheel is we come through and we put that soil density back to the way it was. We can see that the soil density has changed because we carried a row unit weight out here. That's not going to affect our root zone. Or in comparison with a press wheel or gauge wheel right tight to the seed trench, we can see an overlap into the root zone area. Parts that we've changed or improved over on the 2000 series versus the 1200. we look at the gauge wheel arm itself. We incorporated a stop to keep the gauge wheel out of the bearing of the opener disc. The opener disc, we went to a 15-inch diameter. It is mounted on a stud, makes it a lot easier to go through and shim it. It is the same part number disc, leading versus trailing. So we eliminate some parts that we keep on hand. It's a 15-inch opener disc. Okay. Very similar style on the pins yet. The T handle for our depth adjustment. We zero index all our row units from the factory. So that means that when we start off here and put in everybody at the same depth across the planter, we zero index them out at A1. There's a procedure that sets the forming point with the linkage to the T handle. So we go through and we set that. We set everybody here at D4 all the way across the planter. Everybody should be nice uniform depth setting. Okay, the T handle allows us to get 1/4 inch increments every stair step, and if I turn the T handle completely around, I get 1/8 inch adjustment. Okay, the reason that is the lugs are offset. Okay, and they follow the bevel of the handle. So when we were talking about the row unit design, the key drivers in photocopy plants, or 9 to 22% of yield potential according to Purdue, is proper seed depth, uniform correct seed depth across the planter and throughout the field, good seed to soil contact, uniformly correct soil pressure all the way around the seed. So when we look at that, we kept everybody at the same depth with the forming point. We did that with our gauge wheels as well. We kept the same pressure and good seed to soil contact by closing in that seed trench with the moist soil going back to the bottom. Then we come back through and press it, any air pockets out, so that soil density gets back to the same as it was before, and we could see that with the pressure on that press wheel. Okay. The other things that we look into going forward on a planter are picket fence stands. 2 to 4% of your yield potential. That's accurate seed population, accurate in-row seed spacing. A lot of competitors have focused on this for many, many years, that this was the key driver to planting. 2 to 4% of yield potential versus a Case IH early riser row unit focusing on 9 to 22% of yield potential. Okay, that's why we have the early riser name. We're coming out of the ground sooner. We put that moisture back into the seed trench where it belongs, right around the seed, and we also have the same density of soil around it. Okay, so when we look at that even emergence, that even depth, even seed to soil contact, that's going to carry through all the way to yield. So if we've got uneven emergence, we're going to see those plants as we look through the field come up at different growth stages. That's going to affect the cobs. It's going to come right through to that as well. If all the plants come up nice and even, they're going to be all nice and even cobs out in the field. That's going to be our greatest yield potential, is that style. I like one of the sayings that I heard earlier this spring. A guy said that it used to be very important to look at this out in a cornfield. Now this, we know, is the most important thing out in a cornfield. Even emergence, everybody at the same height all the way through the growing season. And that's where we get into the yield from those photocopy plants. Okay, so we have a 2150 air 12 row straight out of the factory. The way we equip the 2150s, we can be 2-point or we can be drawbar when we get into a 16 or 24 row planter. As you can see here on our 2-point model, we're very clean. We have very simple tractor hookup, hydraulic lines all the way to the tractor, and we see that we're utilizing just 3 sets of remotes, case drain, and a couple of electrical connections here. There is option to put a PTO pump on here to pull some of that hydraulic load off onto the PTO pump. Majority of our planters are spec'd with just hookups for tractor hydraulics. When we come back on a 2-point, we look at how the lines are routed, how the clean toolbar looks. We utilize steel lines when we can, and then we utilize flex hose here in the flex areas. Okay, The steel lines also help with reducing the amount of heat that's generated in the system and dissipating some of that heat before we get back to the tractor. Our factory fit fertilizer system is up here. We're set up with three valve control on that for 3 sections. Flow meter, 80 mesh screen are all standard equipment within that factory supplied fertilizer system. Hydraulic drive fertilizer pump. That goes out, and we'll see that later on, that it's plumbed all the way to the wet boom and plumbed all the way in furrow directly from factory. Bulk fill systems, we can run a 50 and a 50 on a 12 and a 16 row planter. When we go to a 21 or a 2150 24 row, that goes to 60 and 60. We go to our big frame planters, our 2160s, we'll run 260s as well. That one can come with a drawbar hitch, and the wing wheels will always carry that planter in transport as well as when it's unfolded. So the wing wheels are always on the ground. That reduces the amount of load on your tractor. Okay. On the bulk fill, we look at the bulk fill, all of our planters offer the inductor box clean out area. We've got a slide. This comes in and shuts off the seed from our bulk fill tanks. So we can go through, close that off. We get our pail underneath here to catch just a little bit of seed that comes out of each one of these doors. When we're folded up on a 2150, it's nice and easy to pull our Pro Box in here, take our doors off, and then we can meter out how much seed that we need to, or all of it. Okay, nice and easily. If we had any issues, we can also just take out a little bit of seed from this box or bulk bin and fill our other bulk bin if we run out on that side, so we can plant out evenly. Keep looking at the toolbar. We can see all of our hydraulic lines are cleanly routed. We come up to the battery box area and the alternator. On our left-hand wings of our planters, we'll always run a hydraulic drive alternator that goes and does all the heavy electrical loads on the system. We also incorporate a Group 31 battery just below it. So this is a standard alternator. It's a Magnum 200 amp alternator. On our big planter, we can upsize that when we need to for row configurations. Our power distribution module here, set up with all our large fuses, as well as our turn compensating gyro is in here. We keep coming around the planter. We can get these set up from factory with markers, or we can come out on a 2150 and do a weight frame out here in place of markers. Now you can see the wet boom assembly here for our fertilizer. So this one was factory equipped all the way from the tanks up there all the way down through to the row unit and plumbed in furrow. So our in furrow fertilizer applicator, you can see, very flexible, and that's mounted roughly 2 inches just above the seed trench. Okay, this is just outside. We're not going to see hardly any wear on this, but we do have plenty of flexibility if we run into rocks, sticks, that type of thing. Components that are different between the 2000 series and a 1200. We remove our pin just like we had before, the washers for shimming. We slide that gauge wheel off. We mentioned that the gauge wheel arm is different. We have the stop incorporated here, the contact frame. That keeps the gauge wheel from contacting the bearing and wearing out the inside of the gauge wheel as well as the bearing itself. The bearing on the disc and the bolt and the hardware, or the nut and the hardware now are changed. It's mounted on a stud, makes it a lot easier to go through, shim that disc. It also has toolless scrapers, so I can go and remove these scrapers and replace them. There is an option to go with a rotary scraper for those that like that style. The disc is the same part number, leading and trailing. Okay, we're still leading edge. Half the planter has the left side leading, the other half has the right side leading. There'll be a stamping right on the row unit itself here to indicate left leading or right hand leading. Makes it easy to do the shimming on the discs. They're a 15-inch opener. The prior planter was a 14-inch opener. When we come back, the closing discs are also a 9-inch opening disc. They're an inch bigger than they were before at 8 inches. Both sets of discs, we still look at a half-inch wear increment as far as when we should start looking at replacing those. We mentioned a modular style closing system. That's different from a 1200 planter, as well as this pin to adjust how deep our discs get into. We still see that our press wheel is very similar in design and function that it was on our 1200 series planter. The T handle makes it a lot easier to go through your depth adjustments. Your crank handle that you had before, you're capable of your 1/4 inch adjustments as well as your 1/8 inch adjustments on that planter, and you can still do that now on this planter. So typically when we're going to start out planting, we're going to be in the E5 setting for 2 inch depth. That's with the bevel facing rearward. If I wasn't quite deep enough there, I needed 2 1/8, I would turn it around still in E5. Okay, otherwise every stair step is a 1/4 inch increment. So this is on a 2160, but a pneumatic closing system is offered on any one of our planters on the 2000 series. But here you can see that pneumatic cylinder is pinned up at the top and comes down to our closing system. Again, that's routed with white and blue air lines all the way over to the air compressor. It's factory integrated right into all the connections here and routed accordingly so that we don't run into any pinching, binding, things of that nature. This is on a planter that has gone through field use already. This also shows what the model year 21 rear closing or press wheel arm looks like as well, and the model year 21 spring assembly is on there. Okay, so if we had this row unit set up with the optional speed tube assembly or the advanced seed delivery, we can see that we put on the correct meter cover. This one's going to be just a clear one for show and tell purposes, but you see that there's a notch on the top here so that it accepts the speed tube assembly. That speed tube assembly is going to come up in there and it will grab right in the vac area the seed right off the plate while the vac is still holding the seed on the plate. So all your singulation is still done up in a meter. The speed tube itself will come out as well. It's just going to be set in some rubber gaskets and a clip. So when we open up the speed tube, we can take our sensor off here. When we go through, unclip it, we can open up the entire speed tube assembly. We see that that's going to be belt delivery all the way down to the bottom of the seed trench. So those rubber rolls are going to go and take that seed right off the meter. They're going to go and place it in a belt flighting. The belt is going to go down at ground speed. So if I'm traveling 5 miles an hour, the belt moves 5 miles an hour. If I go 10, it goes 10. So the belt spacing is going to maintain that seed spacing. So if we're in 35,000 population corn, that's a seed every 6 inches. We would see a seed every 6 inches down this belt. Okay, so we do not singulate with this. We singulate in the meter. We maintain that spacing all the way from up here in the meter all the way down to the seed trench. Literally at the bottom of the speed tube, my finger is here. The bottom of the forming point is right here. That is the distance that gravity can affect seed spacing in a speed tube planter. Okay, so that roller takes the seed, places it in the belt flighting. If by chance it hangs onto the edge of the belt flighting, it'll go past the rumble strip and knock it back 1 slot. Okay, carries it all the way down to the bottom of the seed trench and releases it there. We can see on the belt itself, there's a bevel on there, and there's an indicator right here to show you how to install that belt. Out of season, we're going to take the belt out, hang it in a shed, lay it flat. We'd also go through, then in spring, we'd inspect the belt just like a V-belt, look for any broken areas, things of that nature. Then we loosen this screw and tighten the screw. It automatically self-tensions the belt. Up at the top, we look for wear. We think about this as a front-wheel drive tractor, MFD tractor. Okay, we got a small wheel and a big wheel. Which one are we going to see wear on first? We look at the small wheel. That one's going to be turning faster in relation to how many times it has to turn for the same amount of work. So we look to make sure we have a square profile across there. We have the eye in here. The eye is going to go through, monitor your population just like any other tube. It will also monitor belt flight integrity and let you know if there's an issue with the belt. From the monitor standpoint, we're going to monitor amp draw to this motor on here. It's an independent motor of our meter. And if we ever see a high amp draw on there, it'll think that we might be plugging this up. It would ratchet back and forth to try and clear it. If it doesn't clear it, it shuts it down and tells you that there's an issue in that speed tube. All the components between the roll units are completely interchangeable. So if I have an issue with a speed tube, a monitor, a harness, a meter, I can take that off of this roll unit, swap it over to the next one, bring this one over here, restart my planner, it automatically readdresses. This is no longer roll unit number 2, this is roll unit 1, and vice versa. Okay, I don't have to go into the monitor and tell it I did anything. Okay, when we look at the routing again, look at how the fertilizer is routed in here. This planter is equipped with clean sweep. We are color-coded air lines all the way from clean sweep all the way to the air compressor. We'll get to the air compressor on the other side of the planter in a minute. The fertilizer, it's factory integrated right into the clipping on here. If we had pneumatic closing, that would be white and blue air lines. They would also come through in these extra areas here on the clips and route those all the way to the air compressor. And you see even up on the main toolbar, they are color coded, and it will be that way all the way to the air compressor. The roll unit harness bulkhead is from here. Very simple, very clean install on how all the components work together, and we can swap those row by row. So everything from here back is interchangeable row by row. We can see the cast backbone on the planter itself. We're much heavier on this roll unit now. We're about 50 pounds heavier than we were on our prior 1200 series roll unit. That gave us the ability for more rigidity. We can handle those speeds to go up to that 10 miles an hour. This planter is factory equipped with delta force on it, so we can apply more roll unit down pressure. The standard parallel links on this roll unit are also heavier. They also give us more roll unit travel. We have 16 inches of total roll unit travel. There are poly bushings in each one of the pivot areas here that are replaceable. Okay, when we get down to something like clean sweep, this most common configuration, we see that we have the shark tooth style on here. We've got the protective covers on here yet from factory with the depth bands on here and the clean sweep cylinder. We can fix this if we wanted fixed positioning, as well as let it float, full lift, down pressure, or a little bit of lift pressure to carry these as we go through the field. Okay, again, we're routed all the way through. The load cell is incorporated for that delta force right into our linkage here on our T-handle. Okay, so that's factory integrated as well. We're going to monitor this 200 times a second, and we can change that delta force row by row up to 5 times a second. So when we look at how that's going to affect our planting, we're going to go through, if we plant at 5 miles an hour, 5 times a second is every 1.5 feet. 35,000 population means that that's every 3 seeds, right? Every 6 inches is a seed. So we can change that row unit down pressure or lift pressure. The row unit's heavier now. If I'm in conventional till, peat soil, sand, I can lift this row unit all automatically while it's going through the field, depending on what it's reading here at the load cell and applying the correct pressure or lift pressure here at the cylinder. So this row unit could be in a wheel track, could be in a rut. I may have to push down a little bit harder here, and this one's in fluff or peat, and I might have to lift at the same time. All going through the field, it's row by row, and it'll react accordingly. The toolbar height, we adjusted that to compensate for the more row unit travel. So our toolbar height is going to sit higher than competitors. We're going to be sitting at 26-inch toolbar height when we're in the plant position. So when we look at speed tube, if I go through and I configure my planter properly to start with, and I go with delta force on it and go with pneumatic on a closing system, I could go and get a speed tube kit and install that at any time on my planter. I can change over. I would be able to swap from speed tube to standard tube and vice versa. I could have my standard tubes as backup. I could have, through the whole goods kit, I could run just one speed tube as a trial on my planter to see how it does. But really we need to look at making sure that we have delta force and pneumatic closing on the system in order to get all of our return on investment out of the speed tube to get up to that 10 miles an hour. Okay, we look at the crop changeover. and installing a kit on here. If we just leave it on the row unit itself, everything's still connected. We still have bulk fill filling in. We still have our vac line. We just take our clips off here. We move the meter out to the side. And even while it's still hanging on here, I can go through, remove my pin, take my spring, put my spring in behind my ejector. My ejector will go through, clip right in. I take my disc, my corn discs, line it up to my tabs, line it up to my drive motor, set my clip in. On the other side, need to look in a little bit tighter. Then we go through, line up our tabs, clip in our singulator. I come back, line up my meter, and put on my clips. I can do all of that with everything still intact. My meter was still on there, or I can take it off as I did before and put in that same crop kit or swap over to soybeans. Okay. When we come around to the back, as far as tendering, what we have on this planter, we have all of our fertilizer coming in the back. We also have a gate in the back. Makes it a little bit easier to tender. So when I'm in the yard, I can open up my gate, or out in the field, if I have my pallet of seed, I can raise that up to here. On this planter, we also offer storage mode. Okay, storage mode allows us, when the planter is folded up, I can go in there and activate it. I can lower my center section right down. So that would bring all my row units right down to the ground and bring this deck height from here down to here or so, and make it easier to go through and tender. All while it's still folded up. I don't have to unfold it and get into the plant mode. So I can tender it right in my yard. When we look from the rear of the machine, we also incorporated the VF style tires on the planter itself. So these are capable of handling more load at a lower air pressure. In our 16 row version, we eliminated one pinch row because we went from a 2-tire system on the wings to a single tire, because we can carry all of that load on these new style tires. Okay, eliminating a pinch row. Bex did a study several years ago that's up to 12.5 bushel decrease in your yield potential. So you eliminated 2 of those on a 16 row planter. It's a nice yield bump for you. As we come around to the back of the machine, we can see that we moved our vac to the center. The vac is on a 2150, is mounted in the center of the machine. We run one vac on a 12 and a 16 row, and then we bump up to a 24 row and we run 2 vacs. Okay, we can see the plumbing for a vac is much smaller. The vac plumbing as well, when we look at where the vac plumbing is, we utilize the toolbar itself when we get out here onto the wings, and we can see that the wing toolbar, we have the vac inside the toolbar or the frame member itself. Compressor, so we have our clean sweeps air lines here. If we had our pneumatic closing, that would be in our other air valves here. We can manually adjust or manually check this air compressor to make sure everything's functioning by pushing on the buttons here. It'll function very similar to a shop air compressor. It'll cycle on and off as needed between 125 and 145 psi. Large air compressor filter. Okay, very minimal dust back here compared to our prior ones. We're able to go through, minimal maintenance back here because we're not kicking up as much dust from right behind the tractor tires. And we can see that the air filter on this unit is a lot bigger than our prior one. Okay. When we look at this air compressor, it is hydraulic drive. That's all included in the valving on the tractor or on the planter itself. Daily maintenance here is drain the water out of the air tank for moisture, and a sight glass to make sure we have oil in the air compressor itself. Our bulk fill fan is in the center of the machine. Now we're going to set RPM there to carry out the seed all the way out to each one of the row units. And we've got our bin level sensors here. If we had an option to put scales on, the scales would mount in between this bracket here. We can see that the tracks here, we utilize our undercarriage components, our idlers, and our rollers from our quad tracks, our road track tractors, and we've got a very similar carriage system as well. So every time we raise and lower the planter, we go and hydraulically tension the cylinders on here to keep tension on the track system. So you can see that we have the clear covers here to see the oil levels. Rubber on here. We are utilizing the Continental track on here. This 24-inch belt. We can get them an 18-inch as well for the different row unit spacings that we offer in the 2160s, the 2022s, and in 30-inch planter as well. When we come to the insides on track units, steering is available in transport. So when we're under 10 miles an hour to go in and swoop into a field entrance and out, we can go through and manually steer the tracks with the remote lever and utilizing the steering cylinders there. This frame assembly is going to go through and lift off of the undercarriage here as well. So everything would come up on top, and we can see that our large toolbar, we got a 12 by 12 frame member for that toolbar, as well as when we go through and plumb in our vac into the toolbar. We go and clean up the entire toolbar. We don't have all the vac plumbing coming across the toolbar. We keep everything clean just as we did on the other planter, with the steel tubes where we can utilize them, and then hoses again where we flex. Okay, this system is going to be set up with 2 vacs, one on each wing. Our air compressor and our alternator are mounted in the center of the planter. Bulk fill is going to be very similar as well that we looked at on that 2150. The slide gate will come in from the rear on it to shut off the bulk fill system, and we have our bulk fill sensors on it. Factory supplied fertilizer would mount up in this area as well. We can get a 600-gallon fertilizer tank from factory, and again, all plumbed, integrated right into the planter right from factory. Row cleaners will fit on there as well for clean sweep, and then pneumatic closing and delta force are on this planter as well. So the nice thing about this is we can actually raise our row cleaners right from our display. We go to full lift, and you see all the row cleaners come out. And if we get through a mud hole or something like that where we're trying to raise them to, we can actually just go back to our original setting and go back down on it.
On this row unit, it comes standard from factory. Precision planning VSET 2 electric drive meter, delta force downforce system, optional clean sweep control system, and pneumatic closing. Over here we have the Pro 700 that is fully capable of running all of those systems from factory, and it is also capable of seeing singulation, spacing, fertilizer control, fertilizer monitoring, and HD mapping. From here we have the option to add on a 2020 precision planning display. This is a nice addition, pairs very nicely with the 700, takes some of the functions and runs it on here. If this is what a guy is used to, this is definitely a good solid option. There's other products expandable from here. Pro 700 added with a 2020 display gives a good flexibility for those who want to run the traditional Case IH Pro 700 monitoring system with a newer 2020 display. Over here we have our traditional red ball system to monitor your blockage on a liquid system. We also have hooked into that, we have a precision planning flow sense flow meter. And with that, we can see it on the Gen 3 2020 display. And we can monitor the amount of flow that we see coming through on each row.